Good afternoon. Please. Thank you. Okay, so I hope you managed to finish this question yesterday. Let's just quickly go over it together. We have to integrate cos cubed of x over 2 to the power of 3. And we said that when we have cos or sine to the power of 3, usually you want to break it down with cos squared and then times cos, and then the cos squared you want to rewrite it in terms of sine squared so that you can use the substitution method to work that out. That's number 10. Okay, so when we integrate this, so we said this is the integral, then we write cos squared x over 2 times cos x over 2 dx. The cos squared, we write it as 1 minus sine squared. The integral of 1 minus sine squared x over 2, and then we multiply by cos x over 2 dx, and then we multiply out the brackets. This is the integral of cos x over 2 minus sine squared x over 2 times cos x over 2 dx. So everything we have here is very easy to integrate. The integral of cos x over 2 is just sine x over 2, and then we divide by the derivative of x over 2, which is half. So dividing by half is the same as multiplying by 2. So we will have 2 sine x over 2. And then the same thing with this one over here. You can see that I have sine x over 2 and cos x over 2. This cos x over 2 is the derivative of that, except that there is a half missing. Okay, so what I will do is I will integrate this part here. It becomes to the power of 3. Please keep your mask on the whole time. So this is minus sine to the power of 3 of x over 2. Okay, so when we divide it by 3, that's the first part. When you have u to the power of 2, when you integrate that, it's u to the power of 3 divided by 3. And then you have to divide by the derivative of x over 2. So we divide by half, which is the same as, are you in the right place? Okay. And then we multiply by 2. So this is 2 like that. And then you add your constant of integration. So you have 2 sine x over 2 minus 2 sine cubed x over 2 over 3, and then plus your constant. So that is what you should have gotten. And then number 14, let me see, what does number 14 look like? Okay, let's do number 14 very quickly. Number 14, we have the integral of cos to the power of 5 of 3x dx. So we say this is to the power of 5. So we should rewrite it as cos 3x times cos to the power of 4 of 3x. So we rewrite this as cos the power of 4, 3x cos 3x dx. And then this cos to the power of 4, we write it as cos squared of 3x squared. So this is the integral of cos squared 3x squared times cos 3x dx. And then the cos squared 3x, we rewrite it in terms of sine squared 3x. So this is the integral 1 minus sine squared of 3x squared cos 3x dx. And we know how to expand that binomial. Okay. And then we will get the integral. This is 1 minus 2 sine squared 3x plus sine to the power of 4 of 3x. And then we have to multiply by cos 3x. And don't forget dx there. Okay, so now that we have that, we can easily multiply out the brackets, and you can see I'll either just be integrating cos 3x by itself or a product involving sine and cos. And with that, I just use the substitution method. So this is the integral of cos 3x minus 2 sine squared 3x plus sine to the power of 4 of 3x cos 3x. Yeah.
Also the second term.
What's the second? This one here?
Yeah.
Why or how?
Because I was also not multiplying the cos.
Oh, you mean this one here? Yes. That you're talking about inside the brackets. So this is cos 3x plus sine to the power of 4 of 3x cos 3x dx. Okay, so you multiply out the brackets. Make sure you do that correctly. Then after that, you can now integrate. So we know the integral of cos 3x is just sine 3x divided by 3. And then here, we will just say this is the negative 2 will obviously be there. And then the integral of this is sine to the power of 3 of 3x divided by 3. And then again, we divide by the derivative of 3x, which is 3. So it's like we'll be dividing by 9. And then this one here, x to the power of 4, when we integrate that, it's x to the power of 5 divided by 5. So here it'll be sine to the power of 5 divided by 5. And then we divide by the derivative of 3x, which is 3. So in the denominator, we have 5 times 3. Okay, so let's do that. They say the integral of cos 3x is sine 3x divided by 3. Then our second term is that. Our second term, the minus 2 should be there. And then we say the power of sine must go up by 1. And we have sine to the power of 3 divided by 3. And then we also have to divide by the derivative of 3x. So we're dividing by 3 twice, which is the same as dividing by 9. And then the same thing with the last one, sine to the power of 5 of 3x divided by 5, and then again divided by the derivative of 3x. So this is divided by 15. And then you add your constant of integration. Okay, so again, like I always say, if it's confusing here, what you should do is you should say u is equal to, where's that? Is equal to sine squared 3x, and then du here, this is 2 sine 3x cos 3x. So we have the sine 3x cos 3x, and then you substitute it the way we always do. Otherwise, do it like that. Okay, so are we fine with that? It's always quiet But when I'm walking around, I can see it's not fine. Okay, let's move on to the next type of integrals that we look at. These ones involve powers of a product of sine and cos. So we look at integrals. Of the form sine mx cos nx dx. So previously we just had sine to the power of something by itself, cos to the power of something by itself, and now we see what do we do when we have a product of the two. The idea is pretty much the same. With your odd power, you will try and rewrite it as an even power times 1, and then you can use the identity sine squared plus cos squared is equal to 1. So we use sine squared x, cos squared x is equal to 1. So doing that, let's look at some examples. The first one, we have the integral of sine squared x cos cubed x dx. So we said what we want is usually, as a general rule, the one with the odd power is the one that you want to break it up. So cos to the power of 3 of x, I'll write it as cos squared times cos. So this will give me the integral sine squared x, and then I have cos squared x cos x dx. And then the cos squared x, I can rewrite it as sine squared of x, or in terms of sine squared of x. So this is the integral of sine squared x. I have 1 minus sine squared x, and then cos x dx, and then we'll multiply out. So this is the integral. Here we have sine squared times 1 times cos. This is sine squared x cos x, and this one just by substitution. Your mask, please. I'm also struggling here, but okay. And then we have sine to the power of 4 of x cos x dx. Okay, and yeah, sine and cos, and then sine to the power of 4 cos x. And then you can see here I just use substitution in order to integrate all of these. So for the first one, I will have a sine to the power of 3 of x divided by 3. And then for the second one, I have sine to the power of 5 of x divided by 5. And then you add your constant of integration. So this is sine to the power of 3 of x, you divide by 3, sine to the power of 5 of x divided by 5, and then add your constant of integration. So the more you practice, the easier it'll get for you to know this is what I probably need to do. And like I said, you need to be preparing for the test now already, because we still have a long way to go in integration. And if you wait until the week of the test to learn all these techniques, good luck. The integral of cos 3 to the power of 3 of 2x, and sine squared 2x dx. So here, again, the idea is the same. you can see cos has an odd power. So that odd power is the one that we are going to break up. So we have cos squared times cos, and then the cos squared, we rewrite it in terms of sine squared. So this is the integral of cos squared of 2x, cos 2x, sine squared 2x dx. And then the cos squared, we say we rewrite it as 1 minus sine squared. So this is the integral 1 minus sine squared 2x, cos 2x, sine squared 2x dx. And then we multiply out the brackets. For the first term, I have sine squared 2x times cos 2x. And then the second term, I have sine to the power of 4 of 2x multiplied by cos of 2x. And then your dx must be there. Okay. Okay, and now we just use our substitution method to work this out. The integral of the first one, you can see I have sine and cos next to each other. So I'll have sine to the power of 3 of 2x divided by 3. And then you also have to divide by the derivative of 2x, which is the same as dividing the whole thing by 6. So you will have sine to the power of 3 of 2x divided by 6. So first we divide by 3 because we add 1 there and then divide by 3. And then we're also dividing by the derivative of the 2. That's why we have a 6 there. And then the next one, do it in the same way. This is sine to the power of 5 of 2x. I divide by 5 and then divide again by 2, which is the same as dividing by 10. And then I have my constant of integration, like that. Next, we have cos to the power of 2 over 3 of x, and then sine to the power of 5 of x dx. So here again, we have an odd power for sine this time, but the way we break it up is exactly the same. So that sine to the power of 5, we write it as sine to the power of 4 times sine, and then the sine to the power of 4, we write it as sine squared, and then the sine squared, we write it in terms of cos squared. So this is the integral cos 2 over 3 x there. So the 2 over 3 is an exponent. We treat it like we've been treating all the other exponents. And then we say this is sine squared of x squared times sine of x dx. So that sine squared is sine to the power of 4. And then when I multiply it with another sine, I have sine to the power of 5. Then the sine squared, we write it as 1 minus cos squared. So this is the integral cos 2 over 3 of x, 1 minus cos squared x squared sine x dx. So our bracket there, we have to square it, and we know how to do that. This is the integral cos to the power of 2 over 3 of x. When we expand the bracket, we have 1 minus 2 cos squared x plus cos to the power of 4 of x sine of x, and then dx there. And then now we can multiply out the brackets, and what we have to integrate is not that difficult. So this is the integral. First one, we have this cos times 1 times sine. This is cos to the power of 2 over 3 of x sine x. Then the second one, we have cos times this cos. Remember, when the bases are the same and you're multiplying, you just add the exponents. So you'll say 2 over 3 plus 2. That's 6 plus 2 is 8 over 3. So you have minus 2 cos 8 over 3 of x, and then times sine x. And then the last term, cos to the power of 2 over 3 times cos to the power of 4. You add the exponents again because the bases are the same. That's 12. Yeah, 12 plus 2 is 14. That's what I have here. Yeah, 14 over 3. So you have cos to the power of 14 over 3 of x, and then you multiply by sine x dx. Okay, so once you are here, it's just a matter of using substitution in order to work this out. So the way we will integrate, you'll have cos to the power of this number plus 1 divided by that number. And it should be negative because the derivative of cos is minus. So the first term will be negative because here I have a positive sign, but the derivative of cos is negative. So my first term will be negative. So this is negative cos. Let me just write it on the next page. So we said it is negative, and we said this is cos. The 2 over 3, you add 1, you get 5 over 3. Yeah. Power of 5 over 3 of x, and then you divide by 5 over 3. And then you do the same thing with the second term. Here, there's already a negative there. So my second term can just be positive. The 2 should remain there. And then we'll say 8 over 3 plus 1, and then divide by 8 over 3 plus 1. So we have positive 2 cos to the power of 8 over 3 plus 1 is 11 over 3 of x, and then we divide by 11 over 3. And then the last term, this one will now become negative because the derivative of cos is negative sine, but here we have positive sine. So 14 over 3 plus 1 is 17 over 3. So we have negative cos to the power of 17 over 3 of x over 17 over 3, and then add your constant of integration. So you want to rewrite this so it looks better than what we have now. We will have negative 3 over 5 cos 5 over 3 of x plus 6 over 11 cos 11 over 3 of x minus 3 over 17 cos the power 17 over 3 of x, and then your constant of integration there. Number 4, we have sine.
Idea of 6.
Why?
The second one.
Which second one?
6/11.
The 2 and the 3 multiplied. Okay, so sine squared of x, cos squared of x dx. So this one is a little bit different because with the previous ones, we had an odd power, and we knew that with our odd power, we should rewrite it. That's the one we have to rewrite. But here in this case, the choice is yours. You can write the cos squared in terms of sine squared, which I prefer, because if I write it in terms of cos squared, the derivative of cos is negative sine, and I want to avoid that. But either way, it should still work. So here we have sine squared of x, and then the cos squared is the one that I'm going to rewrite. I have 1 minus sine squared of x dx. And then after this, I multiply out my brackets. Sine squared times 1, you get sine squared, and then sine squared times minus sine squared, you get sine to the power of 4. And yesterday we learned how to rewrite sine to the power of 4. We write it as sine squared squared, and then sine squared, we must rewrite it in terms of our double angle. So this is the integral sine squared x minus sine to the power of 4 of x dx. So sine squared, we rewrite it in terms of our double angle, and this is a half 1 minus cos 2x, that's sine squared. And then sine to the power of 4 is sine squared squared. So I have minus a half. Let me write it like this first. Dx and this is a half 1 minus cos 2x and minus, now the sine squared inside the brackets, I rewrite it. This is a half 1 minus cos 2x squared, and this is all integrated with respect to x. My bracket should be closed here. Yeah, I think now it's fine. Then we can just multiply out our brackets. This is a half for the first one, and then minus a half cos 2x. And then we have to square this first, so you have 1 over 4. So you have the 1 over 4 outside, so minus 1 over 4. And then this bracket here, that's what we need to square. So you have 1 minus 2 cos 2x plus cos squared 2x. Dx. Okay, so half minus half cos 2x, and then minus a quarter, 1 minus 2 cos 2x plus cos squared. Okay, so it's fine. And then now we multiply out the brackets. We combine any like terms if there are any. So this is integral. So I have half, was my first term, then minus a half cos 2x. So I'm just multiplying out the brackets. Then I have minus 1 over 4. Then positive a half cos 2x. and then minus a quarter cos squared, minus a quarter cos squared of 2x dx. So we can see that the half and the minus a quarter, you can combine them. You get a quarter. And then minus a half cos 2x and plus cos 2x, those ones they combine to 0 or they cancel each other out. And then we have minus 1 over 4 cos squared 2x dx. And then cos squared 2x, we rewrite it again in terms of a double angle. So this is a quarter minus the quarter is outside. Then I have a half, 1 plus because it's cos. So I have cos 4x dx. So this is from your double angle identities. Okay, so that's what we have. And we can multiply everything out, and then what we have to integrate will be much simpler than what we started with. So this is the integral of a quarter, and then I have a quarter times a half, that is minus 1 over 8. I have a quarter times half times cos, that is minus 1 over 8 cos 4x dx. And then the quarter and the minus 1 over 4, we combine them. Are you guys okay? Like that. Now this one we should be able to integrate without any problems. Okay, I think it's just a lot of algebra, but there isn't anything difficult that we're doing. So be careful with these numbers, because you make a mistake somewhere at the top, it affects everything going forward. Okay, then we integrate. The integral of a quarter is just, 1 over 8 is 1 over 8x. And then here we're integrating cos. Its integral is positive sign. And then we divide by 4x, by the derivative of 4x, which is 4. So in our denominator, we'll have 32. Is that right? Why is my answer different here? 1 over 8. Okay, I don't know, I think something is wrong there. Okay, so here I have minus sine to the power of 4x, and then we divide by 4 and then divide by, we write it here. So this is minus cos 4x. We divide by 8, and then again we divide by 4, which is 32, and then plus c. Sine. Okay, if we were to differentiate that, we would get cos 4x times 4, and then 4 over 32 is minus 8. And here, why do I have this? Let me just correct that. Okay. Then one more, number 5. With the integral of a sine squared of x cos the power of 4 of x dx. So here our calculations will be much easier if we convert the sine squared and rewrite that in terms of cos squared than the cos squared in terms of sine squared. So doing that, we have the integral 1 minus cos squared of x cos to the power of 4 of x dx. Multiply this out. This is the integral of cos to the power of 4 of x dx minus cos to the power of 6 of x dx. Then we can rewrite each of these as cos squared to the power of something else. So this is the integral of cos squared of x squared minus cos squared of x to the power of 3 dx. And then we rewrite this using our double angle identities. So this is the integral of a half 1 plus cos 2x to the power of 2, then minus a half 1 plus cos 2x to the power of 3 dx. Okay, so now we just have to use the binomial theorem to expand this. But again, nothing difficult. Just be careful with your calculations. So I have a quarter here, and then 1 plus 2 cos 2x plus cos squared of 2x. That's from the first one. And then minus 1 over 8, 1 plus 3 cos 2x plus 3 cos squared 2x plus cos to the power of 3 of 2x dx. So your binomial theorem, which we did last semester. So if you don't remember, go and find your notes. Whew. Okay, so we've expanded that one. Now we can multiply the quarter and the 1 over 8 inside and then see if there are any like terms that we can combine. We okay? We're not even at the hard part yet. And I told you this is a very long chapter. So this is the easy part. Okay, so now just multiply out the brackets. So we have the integral. We have a quarter. Then I have a quarter times 2 is a half cos 2x. And then I have a quarter times cos squared of 2x. Then I have minus 1 over 8 times 1. Then I have minus 1 over 8 times 3 cos 2x. That's minus 3 over 8 cos 2x. 3 over 8 cos 2x. Then minus 1 over 8 times 3 cos squared 2x. Minus 3 over 8 cos squared 2x. Then there is minus 1 over 8 times cos to the power of 3 of 2x. Of 2x, then dx. Now we look for any like terms. You can see I have a quarter and 1/8. You combine those, that will give us 1/8. So this is the integral of 1/8. And then I have a half cos 2x and minus 3/8 cos 2x. We add those two together. What is that? That's 4 minus 3. Yeah, 1/3. That's not what I got. No, 1/8. Yeah. So that's positive 1/8 cos 2x. So let's just write them. So we have this one here and that one there. Then we have the cos squared, this one here, and that one there. So we have 1/4 minus 3/8 cos squared of 2x. That is 2 minus 3, which is negative 1/8, negative 1/8 cos squared 2x. Yeah. And then the last pair we have, oh, it's by itself. Okay. Then minus 1/8 cos cubed 2x dx. Let me just see if here I have, where's that? Again here, why is this a quarter? Okay, that minus that. Okay, it's fine. Just need to fix this. Okay, so the first two terms, they're easy to integrate. But then these two here, cos squared and cos to the power of 3, we need to rewrite them. So cos squared, we will rewrite it as using the double angle identity. And then this one here, we have to rewrite as cos squared times cos. And then the cos squared, we can rewrite in terms of sine squared. Okay, so this is the integral 1/8. And then 1/8 cos 2x. Then minus 1/8. We say the cos squared, this is a half. 1 plus cos 4x. And then minus 1/8 cos to the power of 3. We say this is cos squared 2x times cos 2x dx. So here we just have to multiply out the brackets, then everything there, if there are any like, no, there won't be any like terms. It's very easy to integrate. This one, we must rewrite it in terms of sine squared. So we have the integral, yeah.
Why can't we use the double angle then?
Where?
Like cos squared.
Where is cos squared?
Like minus 1/.
Which step?
The last step.
This one. Oh, you can't even see. This one here.
Yes. Why can't we use the double?
Because we'll then have cos to the power of 4 multiplied by cos to the power of 2. How will you integrate that? Okay, so here, oh, this is So we have 1 over 8, and then 1 over 8 cos 2x. And then 1 over 8 times half is 1 over 16. I have minus 1 over 16. And then I have 1 over 16 cos 4x. And then we said cos squared, we must rewrite it as 1 minus sine squared. So this is minus 1 over 8, 1 minus sine squared of 2x. And then this has to be multiplied by cos 2x. Then dx. Okay, we're almost there now. So this is now the integral. So you can see I have 1 over 8 and minus 1 over 16. I can combine those to get 1 over 16. Then 1 over 8 cos 2x. Then minus 1 over 16 cos 4x. Then we need to multiply 1 over 8 cos 2x. So we have minus 1 over 8 cos 2x. And then I have negative, negative. That will give me positive. So I have positive 1 over 8 sine squared of 2x. Sine squared of 2x cos of 2x dx. Okay, and then we can see that this term here and that one there, they will cancel out. So I have the integral of 1 over 16 minus 1 over 16 cos 4x, and then 1 over 8 sine squared 2x cos 2x dx. Now everything here I can easily integrate without any problems. So the integral of 1 over 16, this is x over 16. And then the integral of cos 4x is sine 4x divided by 4, and then the 4 will have to multiply by the 16. So I have minus sine 4x over 64. And then here, sine squared of 2x cos 2x, that is where we use substitution. So the integral, the 1 over 8 is going to be outside. And then we have sine to the power of 3 of 2x. We're dividing by 8, the 1 over 8 outside. And then we still divide by the derivative of, we divide by 3. And then we divide by 2 again. And then we're dividing by 8. So it's 8 times 3 times 2. What is that? It's 8 times, it's 64. 6, we say this is, we have 8 times 3 times 2. This is 8 times 6, 48. 40, yes, 48, because 8 times 5 is 40. So this is 48. And then finally, you get your 8 marks, just like that.
Oh, no, just like
All
just
that.
Like
What?
it's long.
Yeah, it was long. That's why it's 8 marks.
5 minutes in the whole.
5 minutes. How much should it be? 5 marks. 11. You will get this question in the test.
We'll get this question.
Obviously, you will. For sure, you will get questions. Not this one specifically. You will get questions like this. Anyway, let's, now we have like 5 minutes or so. You guys can do the questions in the exercise. So exercise 4.4. Let's look at number 15. What is number 15? So I would like to see how you guys do that one. This is the integral of sine squared x cos to the power of 3 of x dx. Then number 15, number 16 as well. The integral, this one is a definite integral, so we should remember what that means. Here we are integrating from 0 to pi. From 0 to pi, and we have cos squared of x sine to the power of 5 of x dx. Number 17, you have, is it number 17? Now, what do you have to do? We have sine to the power of 3 of 2x cos to the power of 4 of 2x dx. And number 18 as well. Here's number 18. It's only 4 questions. Yeah. That's how you practice being fast. Yeah, why not? Some are easier than others. Yeah. Not tougher, longer. That's it. No, what was tough about what we did, honestly? But if you write the correct things, how, even if I mark strictly, how does that affect anything? Okay, so let's do these ones. I'd like to see how you guys do them. Did we all sign the register? break it down. Square.
One. Yeah. That's one mark. Two. Don't do it into the same.
One integral, one the next to each other. Ask yourself, can I not appreciate
Forsake this one. They want to go. That's the first time. I think the first time they're telling me.
Sine and cos next to each other, and you can use Usually, remember, as a rule, the one with the odd power is the one that we break up. It's possible sometimes to break up the even one and you get something that you can integrate, but when you have a choice, rewrite the one with the odd power. Okay. Okay, so finish the rest. We'll continue tomorrow. Yeah. Number 16, I have minus cos to the power 3 of x over 3. Oh, no, sorry, 8 over 105. Okay, do the rest. Let's go over them tomorrow. Tomorrow we meet at 8:30. Please come on time. Bye.